Welcome back to Sleepy Science Truths, a place where the universe slows down and your mind can finally rest. Tonight, you're not here to rush through information. You're here to gently drift through it, to explore the vastness of the universe in a calm, quiet way, where every fact feels like a soft whisper rather than a loud explanation. As you settle in, imagine the universe not as something overwhelming, but as something peaceful, a place where galaxies move slowly, stars burn steadily, and time itself stretches softly across endless space. In this journey, you'll discover 100 quiet truths about the universe, from its mysterious beginning, to the slow birth of stars, to the unseen forces shaping everything, and even the distant future where everything fades into calm stillness. There's no need to focus too hard, no need to remember everything. Just listen and let the ideas flow gently through your mind, because the universe doesn't rush, and neither should you. So take a slow breath, get comfortable, and allow yourself to drift into the quiet rhythm of space as we begin. Chapter 1. The quiet beginning of everything, long before there were stars, before galaxies, before even the faintest glow of light. The universe existed in a state so simple and yet so incomprehensible that even modern science struggles to fully describe it. If you could travel back far enough, beyond time as we know it, you would not find space filled with darkness, because even darkness requires space to exist. Instead, you would find something closer to pure potential, a compressed state where everything that would ever exist was contained in a single, unimaginably dense point. This is what we refer to as the beginning, often called the Big Bang, though the name can be misleading. It was not an explosion in space, but rather an expansion of space itself. There was no center, no edge, and no direction from which it began. Every point in the universe today was once part of that same origin. In a sense, wherever you are right now, that is where it all began. The first truth that quietly shapes everything is that the universe did not expand into anything. There was no empty void waiting for it. Space itself was created as it expanded, stretching outward and carrying energy with it. Imagine inflating a balloon, but instead of expanding into a room, the balloon itself creates the room as it grows. This is the nature of cosmic expansion. In those earliest moments, time behaved very differently from what we experience now. The second truth is that time itself may not have existed in a meaningful way before this expansion. Without change, without motion, and without space to measure events, time becomes undefined. What we call before the beginning may not be a valid concept at all. As the universe expanded, it cooled. And this cooling allowed something extraordinary to happen. The third truth is that the first particles, the building blocks of everything, began to form within fractions of a second. Quarks, electrons, and neutrinos emerged from pure energy, following rules that still govern the universe today. These particles would later combine to form protons and neutrons, setting the stage for atoms. But in those early moments, the universe was not calm. It was intensely energetic, almost chaotic. Temperatures were so high that particles could not remain stable for long. Everything collided constantly, forming and dissolving in a continuous dance. And yet, within this chaos, patterns began to emerge. The fourth truth is that the laws of physics were already in place even then. Gravity, electromagnetism, and nuclear forces began shaping how particles interacted. These forces determined which structures could survive and which would fade away. Without them, the universe would have remained a formless sea of energy. As seconds turned into minutes, the universe continued to cool further. And with that cooling came one of the most important transitions in cosmic history. The fifth truth is that within the first few minutes, the first atomic nuclei formed, primarily hydrogen and helium. These simple elements would become the foundation for every star, every planet, and every living being that would ever exist. But something was still missing. Even though nuclei had formed, electrons were still moving too energetically to settle into stable orbits. This meant that atoms, as we know them, could not yet exist. The universe remained opaque, like a dense fog where light could not travel freely. And this leads us to the sixth truth. For hundreds of thousands of years, the universe was filled with light that could not escape. Photons, the particles of light, were constantly scattered by free electrons. It was only later, when the universe cooled enough, that electrons finally combined with nuclei to form neutral atoms. This moment allowed light to travel freely for the first time. That ancient light still exists today. It has stretched and cooled over billions of years, becoming what we now detect as the cosmic microwave background. The seventh truth is that this faint glow is essentially a snapshot of the universe when it was just 380,000 years old. When we observe it, we are looking back in time, seeing the universe in its infancy. But even in that early universe, something curious was happening. The eighth truth is that the distribution of matter was not perfectly uniform. Tiny fluctuations existed, slight differences in density that would eventually grow under gravity's influence. These small irregularities were the seeds of galaxies, stars, and planets. Without those fluctuations, the universe would be vastly different. Matter would be spread evenly, with no structures, no stars, and no life. It is because of these tiny imperfections that everything we know was able to form. As the universe continued expanding, these denser regions began to pull in more matter, slowly growing over millions of years. Gravity, though the weakest of the fundamental forces, played a crucial role here. It acted patiently, drawing matter together, shaping the large-scale structure of the cosmos. And here lies the ninth truth. The universe we see today is the result of incredibly slow processes. While the beginning was rapid and energetic, the formation of structures like galaxies took hundreds of millions of years. It is a reminder that not all creation is explosive. Much of it is gradual, almost silent. Perhaps the most humbling realization comes with the 10th truth. Everything in the universe, including you, originates from those early moments. The atoms in your body were forged through processes that began shortly after the universe itself came into existence. In a very real sense, you are not separate from the universe. You are a continuation of it. And as you imagine this vast timeline, stretching from a single point of origin to the complexity of the present moment, there is a quiet comfort in knowing that the universe did not rush. It unfolded step by step, layer by layer, guided by simple rules that gave rise to unimaginable complexity. If you listen closely, beyond the noise of everyday life, there is something deeply calming about this story. A universe that began in silence, expanded without urgency, and slowly built everything we see, including the very thoughts you are having right now. And as this thought settles in, the mind begins to drift, gently carried along the timeline of existence, moving from the intensity of the beginning toward the slower rhythms that would eventually give rise to the first stars. As the universe continued its slow and steady expansion, something subtle yet profoundly important began to take shape. The faint fluctuations in density, those tiny irregularities left behind from the earliest moments, started to grow ever so slightly stronger. Gravity, though gentle and patient, began its quiet work, pulling matter toward regions that were just a little denser than the rest. Over vast stretches of time, these regions accumulated more and more matter. Clouds of hydrogen and helium drifted together, gradually becoming thicker, heavier, and warmer. There was no sudden moment of creation here, no dramatic event marking the shift. Instead, the 11th truth reveals itself in this slow unfolding. The universe builds complexity through persistence, not urgency. As these clouds grew denser, their internal pressure increased. Gravity pulled inward, while heat pushed outward. For a long time, these forces balanced each other, holding the clouds in a delicate equilibrium. But eventually, in certain regions, gravity gained the upper hand. This leads us to the 12th truth. The first stars were born not in isolation, but within massive clouds of gas collapsing under their own weight. As the core of these clouds compressed further, temperatures rose dramatically, reaching millions of degrees. At that point, something remarkable happened. Nuclear fusion ignited. For the first time since the early moments of the universe, energy was being generated in a stable, sustained way. Hydrogen atoms fused into helium, releasing enormous amounts of light and heat. These first stars were not like the ones we see today. They were larger, hotter, and far more short-lived. The 13th truth is that the first stars lived fast and died young. Because of their immense size, they burned through their fuel quickly, often lasting only a few million years. But in their brief existence, they played a crucial role in shaping the universe. Inside these stars, new elements were forged. Carbon, oxygen, and other heavier elements began to form through nuclear reactions. When these stars reached the end of their lives, many of them exploded in powerful supernovae, scattering these elements into space. And so, the 14th truth emerges: everything beyond hydrogen and helium was created inside stars. The iron in your blood, the oxygen you breathe, the calcium in your bones. All of it was once part of a star that lived and died billions of years ago. As these elements spread through space, they enriched the surrounding gas clouds, allowing for the formation of new generations of stars. These later stars were different. They contained heavier elements, which made it possible for planets to form around them. The 15th truth is that planets are a natural byproduct of star formation. As stars form, leftover material begins to orbit them, gradually clumping together to create planets, moons, and other structures. Our own solar system formed in this way, long after the first stars had already lived and died. But even as stars and galaxies began to take shape, the universe itself continued to expand. And this expansion was not slowing down as once expected. Instead, it was accelerating. This brings us to the 16th truth. Something unknown is driving the universe apart at an increasing rate. Scientists call this dark energy, but its true nature remains one of the greatest mysteries in modern physics. It makes up most of the universe, yet we cannot see it or directly detect it. While dark energy pushes space outward, gravity continues to pull matter together locally. This creates a balance where galaxies form and evolve even as the universe as a whole stretches farther apart. The 17th truth is that galaxies are not scattered randomly. They form vast structures, clusters, filaments, and walls, separated by enormous voids. On the largest scales, the universe resembles a cosmic web, with galaxies tracing out invisible patterns shaped by gravity and dark matter. Dark matter itself introduces the 18th truth. Most of the matter in the universe is invisible. It does not emit or reflect light, yet its gravitational influence is essential for the formation of galaxies. Without it, the structures we observe today would not have been able to form. As galaxies evolved, they became environments of incredible diversity. Some grew massive and luminous, while others remained small and faint. Within them, stars continued to form, live, and die, recycling material in an ongoing cosmic cycle. And yet, despite all this activity, the universe on the largest scales remains remarkably quiet. There are no sounds in space as we experience them on Earth. No echoes, no vibrations carried through air. Instead, everything unfolds in silence. This leads to the 19th truth. The universe is not only vast but also profoundly silent. Even the most powerful events, like supernovae or black hole collisions, occur without sound in the traditional sense. It is a reminder that much of reality exists beyond our everyday senses. And as you imagine this silent expansion, galaxies drifting apart, stars flickering into existence and fading away, there is a certain calm that begins to settle in. The universe does not hurry. It does not rush toward an end. It simply continues, moment by moment, following the same fundamental rules that have guided it since the beginning. Finally, we arrive at the 20th truth. The story of the universe is still being written. Every moment, new stars are born, new structures form, and new mysteries emerge. Even now, as you rest and listen, the universe continues its quiet evolution. And perhaps the most soothing thought of all is this: you are part of that story, not separate from it, but woven into its fabric. The same processes that shaped the stars also shaped you. The same laws that govern distant galaxies are at work within every atom of your body. As this realization gently settles, the vastness of the universe no longer feels overwhelming. Instead, it feels like something you belong to, as something steady, continuous, and endlessly unfolding. And as the mind drifts further, carried by the rhythm of this cosmic story, it becomes easier to let go, to relax, and to follow the quiet flow of the universe into rest. Chapter 2. The first light in a dark universe. After the universe cooled enough for atoms to form and light to finally travel freely, there was a long, quiet stretch of time that followed, a period often referred to as the cosmic dark ages. It may sound dramatic, but in reality, it was a calm and gradual phase, where the universe was filled mostly with neutral hydrogen and helium, drifting silently through expanding space. There were no stars yet, no galaxies shining across the void, and no sources of visible light as we know them today. The faint glow of the early universe had already stretched into longer wavelengths, becoming softer and colder over time. And so, the universe entered a state of gentle darkness, not empty, but waiting. The 21st truth is that darkness in the universe is not the absence of existence, but simply the absence of light sources. Even in this early era, matter was everywhere, slowly moving, slowly gathering, guided by gravity's quiet influence as time passed. Those tiny fluctuations in density continued to grow. Regions that were slightly denser began pulling in more gas, forming vast clouds that stretched across unimaginable distances. These clouds did not collapse instantly. Instead, they evolved gradually, cooling and compressing over millions of years. The 22nd truth is that the first light did not appear suddenly, but emerged from a long process of accumulation and transformation. The universe was patient, allowing conditions to develop slowly before igniting its first luminous objects. Eventually, within some of these dense regions, gravity became strong enough to trigger collapse. As gas fell inward, it heated up, becoming denser and hotter at the core. And just like in the earliest stars described before, nuclear fusion began. The 23rd truth is that the first stars marked the end of the cosmic dark ages. These stars, often called population 3 stars, were unlike anything we see today. They were composed almost entirely of hydrogen and helium, making them extremely massive and incredibly bright. These early stars burned with an intensity that is difficult to imagine. Without heavier elements to regulate their structure, they grew to enormous sizes, sometimes hundreds of times more massive than our sun. Their light pierced through the darkness, illuminating the surrounding space for the first time. But their light did more than simply shine. it transformed the universe itself. The 24th truth is that the radiation from the first stars began to reionize the universe. This means that the neutral hydrogen atoms, which had formed earlier, were broken apart again into protons and electrons by high-energy photons. This process changed how light interacted with matter, making the universe more transparent. This era, known as reionization, was not instantaneous. It happened gradually as more stars formed and emitted radiation. Bubbles of ionized gas expanded outward from these stars, eventually overlapping and filling the universe. As these early stars lived out their short lives, they ended in powerful explosions, scattering heavier elements into space. These elements mixed with surrounding gas, enriching it and setting the stage for new generations of stars. The 25th truth is that each generation of stars builds upon the last, increasing the complexity of the universe over time. The first stars created the ingredients needed for planets, and eventually for life itself. As more stars formed, they began to cluster together under gravity. These clusters grew larger, merging and interacting, eventually forming the first galaxies. These early galaxies were smaller and more irregular than the ones we see today, but they were the beginnings of the vast structures that now fill the cosmos. The 26th truth is that galaxies did not form fully formed, but grew through a process of merging and accumulation. Small structures combined to create larger ones, a pattern that continues even now. Within these young galaxies, stars formed at a rapid pace. Gas clouds collapsed repeatedly, creating bursts of star formation that filled galaxies with light. Over time, these galaxies evolved, becoming more structured and organized. At the centers of many of these galaxies, something even more mysterious began to form. The 27th truth is that supermassive black holes appeared surprisingly early in the universe. Even in these young galaxies, black holes millions or billions of times the mass of the Sun began to emerge. How they formed so quickly remains one of the great unanswered questions in astrophysics. These black holes influenced their surroundings, pulling in matter and releasing enormous amounts of energy. In some cases, they created quasars, incredibly bright objects that could outshine entire galaxies. The light from these quasars traveled across vast distances, reaching us billions of years later. When we observe them today, we are seeing the universe as it was in its early stages, offering a glimpse into its distant past. The 28th truth is that looking deeper into space is the same as looking back in time. Because light takes time to travel, the farther away an object is, the older the image we see. In this way, telescopes act as time machines, allowing us to study the history of the universe. As galaxies continued to form and evolve, the universe became more structured. Large-scale patterns emerged, with galaxies clustering together in vast networks connected by filaments of matter. Between these filaments lay enormous voids, regions with very few galaxies. These voids are not completely empty, but they are far less dense than the surrounding regions. The 29th truth is that the universe is mostly empty space. Even within galaxies, the distances between stars are so vast that if you scaled the Sun to the size of a grain of sand, the nearest star would still be kilometers away. And yet, despite this emptiness, the universe is filled with light. Stars shine, galaxies glow, and radiation travels endlessly through space, carrying information about distant events. As this light moves through the universe, it stretches along with the expansion of space. This stretching shifts the light toward longer wavelengths, a phenomenon known as redshift. The 30th truth is that the expansion of the universe affects light itself. The farther light travels, the more it is stretched, allowing scientists to measure how fast the universe is expanding. This discovery has led to profound insights about the nature of the cosmos, revealing not only its history but also its possible future. And as you imagine this transition from darkness to light, from a quiet, dim universe to one filled with glowing stars and evolving galaxies, there is something deeply calming about the process. It was not sudden, not chaotic in the way we might expect, but gradual, unfolding step by step. The first light did not rush into existence. It emerged gently, shaped by gravity, guided by the laws of physics, and carried across the universe in silence. And as that light continues to travel, even now, it passes through space, through time, and eventually reaches observers like us, offering a quiet connection to the earliest moments of illumination. As this thought lingers, the mind begins to slow, following the steady rhythm of cosmic evolution, drifting through a universe that once knew darkness, and slowly, patiently learned to shine. As the first stars continued to ignite across the universe, their light did more than simply illuminate the darkness. It began to reshape the cosmos itself. The radiation pouring from these early stars interacted constantly with the surrounding gas, altering its state and influencing how future structures would form. It was a slow transformation, but one that would define the universe for billions of years to come. The 31st truth is that light is not passive in the universe. It does not merely reveal what exists, it actively changes it. The energy from early stars heated nearby gas, preventing some regions from collapsing while encouraging others to evolve differently. In this way, light became a sculptor, shaping the future distribution of matter. As more stars formed, their combined radiation gradually completed the process of reionization. The once neutral hydrogen that filled the universe became ionized again, making space more transparent to light. This transition marked a turning point from a foggy, obscured universe to one that allowed light to travel vast distances without interruption. With this clarity came the 30-second truth: the universe became observable. Not in the sense that observers existed yet, but in the sense that information could now travel freely. Light carried stories across space, preserving the history of stars, galaxies, and cosmic events. Meanwhile, galaxies were growing more complex. They merged, collided, and interacted in ways that shaped their structure. Some galaxies became spiral, with elegant arms stretching outward, while others formed into elliptical shapes, more rounded and diffuse. The 33rd truth is that galaxies are dynamic, ever-changing systems. They are not fixed or permanent structures, but evolving collections of stars, gas, and dark matter. Over time, their shapes and compositions shift, influenced by gravity and interaction. In the hearts of many galaxies, supermassive black holes continued to grow. As they consumed surrounding matter, they released enormous amounts of energy in the form of radiation and jets. These energetic processes could influence entire galaxies, regulating star formation and altering their development. The 34th truth is that even the most destructive forces in the universe can play a creative role. Black holes, often associated with endings, can also shape beginnings by controlling how galaxies evolve. As galaxies clustered together, forming groups and clusters, the large-scale structure of the universe became more defined. Filaments of matter stretched across space, connecting massive clusters like threads in a vast cosmic web. Between these filaments, voids expanded, immense regions where very little matter existed. These voids grew larger as the universe expanded, emphasizing the contrast between dense regions and emptier ones. The 35th truth is that structure in the universe arises from contrast. Without differences in density, there would be no galaxies, no clusters, no patterns at all. It is the imbalance that creates form. Within galaxies, new stars continue to form from collapsing clouds of gas. But unlike the first generation, these stars contained heavier elements, allowing for greater diversity in their properties. Some were small and long-lived, while others were massive and short-lived. The 36th truth is that the universe produces variety through repetition. The same basic processes, gravity, fusion, and motion, create an endless range of outcomes depending on conditions. Among the stars that formed in later generations were those capable of supporting planetary systems. Dust and gas surrounding young stars began to coalesce into solid bodies, gradually forming planets, asteroids, and comets. These processes were not unique. They occurred across countless star systems, suggesting that planetary formation is a common feature of the universe. The 37th truth is that planets are likely abundant throughout the cosmos. Observations have confirmed thousands of exoplanets, and many more remain undiscovered. Some orbit close to their stars, while others drift farther away, each system offering its own unique configuration. As planetary systems formed, the potential for more complex chemistry increased. On at least one planet, Earth, these conditions eventually gave rise to life. While the exact process remains a subject of study, it highlights the remarkable potential hidden within the universe's basic ingredients. The 38th truth is that complexity can emerge from simplicity. From hydrogen and helium, through countless interactions and transformations, the universe has produced molecules, cells, and conscious beings capable of reflecting on their own origins. And yet, despite this complexity, the universe remains governed by simple laws. Gravity pulls, light travels, matter interacts, and from these rules, everything else emerges. As time continued, galaxies matured. Star formation slowed in some regions, while continuing actively in others. Older stars aged and faded, while new ones took their place, maintaining a balance within galaxies. The 39th truth is that the universe is constantly recycling itself. Stars are born, live, and die, returning material to space, where it can be used again to form new stars and planets. This cycle has been ongoing for billions of years and will continue far into the future. It is a process without urgency, unfolding steadily across cosmic time. Meanwhile, the expansion of the universe continued to accelerate, driven by dark energy. Galaxies moved farther apart, increasing the distances between them. Over time, this expansion will isolate galaxies, making the universe appear emptier from any given point. The 40th truth is that the universe is gradually becoming more isolated. While structures remain bound by gravity locally, the larger-scale expansion ensures that distant galaxies will eventually move beyond our observable reach. And yet, even as distances grow, the light that has already been emitted continues its journey. Photons released billions of years ago still travel through space, carrying with them the history of the universe. As you imagine this vast interplay of light, matter, and time, there is a gentle rhythm to it all. Nothing rushes, nothing is forced. Each process unfolds according to the same quiet rules that have guided the universe since its beginning. The first light that ended the cosmic dark ages was not a single moment, but a gradual awakening. A slow illumination that continues even now, as new stars are born and new galaxies evolve. And as this realization settles in, there is something deeply calming about knowing that the universe does not demand anything from you. It simply exists, expanding, evolving, and continuing its quiet story. You are part of that story, carried along with it, just as light is carried across space. Steadily, gently, and without resistance. And as the mind drifts further into this calm, the glow of those first stars seems to linger, soft and distant, like a memory of light emerging from darkness, guiding everything that followed. Chapter 3: The Hidden Architecture of Space-Time. As the universe grew brighter with the formation of stars and galaxies, something far more subtle continued to shape everything behind the scenes, something invisible, yet fundamental to all existence. It is not made of matter nor energy in the traditional sense, yet it governs how both behave. This quiet framework is what we call space-time, the underlying structure within which the entire universe unfolds. To understand it gently, imagine space and time not as separate things, but as a single woven fabric. Every object, every event, every moment exists within this fabric, moving through it in ways that are both predictable and deeply mysterious. It stretches, bends, and responds to the presence of mass and energy, shaping the paths that objects take. The 41st truth is that space and time are not fixed backgrounds. They are dynamic, capable of change. Massive objects like stars and planets do not simply exist in space. They alter it. They curve the fabric of space-time around them, creating what we perceive as gravity. This idea may feel abstract, but its effects are something we experience constantly. When you stand on the ground, you are not being pulled down in the traditional sense. Instead, you are following the natural curvature of space-time created by the mass of the Earth. The 42nd truth is that gravity is not a force in the usual sense, but a result of curved space-time. Objects move along paths determined by this curvature, like marbles rolling across a gently warped surface. This concept, first described in detail by Albert Einstein, changed our understanding of the universe completely. It revealed that the geometry of space itself is not flat, but shaped by the presence of matter and energy. As you imagine this fabric stretching across the universe, it becomes clear that everything is connected through it. The movement of galaxies, the orbit of planets, even the path of light, all are guided by the structure of space-time. The 43rd truth is that light, though it has no mass, still follows the curvature of space-time. When light passes near a massive object, its path bends. This effect, known as gravitational lensing, allows us to observe distant galaxies that would otherwise be hidden from view. In a way, massive objects act like cosmic lenses, bending and magnifying light from behind them. This phenomenon has become an important tool in astronomy, helping scientists map the distribution of matter in the universe. But space-time is not only curved, it is also constantly expanding. As the universe grows, the fabric itself stretches, increasing the distance between objects that are not bound together by gravity. The 44th truth is that expansion is happening everywhere at once. It is not that galaxies are moving through space away from each other, but that the space between them is growing. This subtle distinction changes how we think about motion on a cosmic scale. And as space expands, it carries light with it, stretching its wavelength. This is why distant galaxies appear redshifted. Their light has been stretched over billions of years as it traveled through expanding space. Time, too, is part of this fabric, and it behaves in ways that are not always intuitive. The 45th truth is that time does not pass at the same rate everywhere. In regions of strong gravity, time moves more slowly compared to regions with weaker gravity. This effect, known as gravitational time dilation, has been measured and confirmed through precise experiments. Even on Earth, time passes slightly slower at sea level than it does at higher altitudes, though the difference is extremely small. Near massive objects like black holes, however, the effect becomes dramatic. This leads to a deeper realization: time is not universal. It is relative, shaped by both gravity and motion. The 46th truth is that moving objects experience time differently. As an object approaches the speed of light, time for that object slows down relative to a stationary observer. This phenomenon, called time dilation, has been tested using high-speed particles and atomic clocks. In everyday life, these differences are too small to notice. But at extreme speeds and gravitational conditions, they become significant, altering how events are experienced. As space-time bends and shifts, it can also ripple. The 47th truth is that gravitational waves travel through space-time like gentle ripples on water. These waves are created when massive objects accelerate, such as when two black holes merge. The waves carry energy across the universe, subtly stretching and compressing space as they pass. For a long time, these waves were only predicted, but in recent years they have been directly detected, confirming yet another aspect of how space-time behaves. And as these ripples move outward, they pass through everything, including us, though their effects are far too small to feel. Space-time also defines what we can and cannot observe. The 48th truth is that there is a limit to how much of the universe we can see. Because light travels at a finite speed, we can only observe regions from which light has had time to reach us since the beginning of the universe. This boundary is known as the observable universe. Beyond this sima, there may be much more, perhaps infinitely more, but it remains inaccessible to us. And yet, even within this observable region, the scale is almost impossible to comprehend. Billions of galaxies, each containing billions of stars, all moving within this vast, expanding fabric. As we continue to explore, questions arise about the nature of space-time itself. The 49th truth is that space-time may not be continuous at the smallest scales. Some theories suggest that at extremely tiny distances, it could have a discrete structure, like a fabric woven from individual threads rather than a smooth surface. This idea remains unconfirmed, but it hints at a deeper level of reality that we have yet to fully understand. And finally, as we reflect on all of this, we arrive at the 50th truth. Space-time is not just the stage on which the universe exists. It is an active participant in the story. It shapes motion, influences time, and connects everything in a single, unified structure. As you let this idea settle in, the complexity begins to soften into something more calming. A universe where everything is connected, where movement follows gentle curves, where time flows differently depending on where you are. It becomes less about understanding every detail and more about sensing the quiet order beneath it all. And as your thoughts drift along this vast fabric, following its curves and rhythms, there is a sense of being carried, not separate, but part of this continuous, flowing structure. A universe not of chaos, but of quiet geometry, stretching endlessly softly, guiding everything within it. As the understanding of space-time deepens, it begins to feel less like a distant scientific idea and more like something quietly present in every moment. The fabric that bends around stars and stretches across galaxies is the same fabric that holds your place in the universe right now. And as we continue exploring it, the picture becomes even more subtle, even more fascinating. The 51st truth is that motion through space is always tied to motion through time. Every object moves through space-time at a constant speed, but that motion is divided between space and time. When an object moves faster through space, it moves more slowly through time, and when it is still in space, it moves fully through time. This idea may seem abstract, but it reflects a deeper balance built into the universe. Nothing can exceed the speed of light because doing so would require breaking this balance, something the structure of space-time itself does not allow. As objects move and interact within this structure, paths begin to form, not straight lines in the usual sense, but curves shaped by the geometry of space-time. The 52nd truth is that objects follow the straightest possible paths in curved space-time, known as geodesics. These paths may appear curved to us, but they represent the most natural route within a warped geometry. Planets orbit stars not because they are being pulled in a simple way, but because they are following these curved paths. And as space-time curves, it can do so in extreme ways under certain conditions. Near incredibly dense objects such as black holes, the curvature becomes so intense that it creates regions from which nothing can escape. These boundaries, often called event horizons, mark a point beyond which the structure of space-time itself folds inward. The 53rd truth is that at an event horizon, space and time effectively switch roles. Moving forward in time becomes as inevitable as moving inward toward the center. There is no path that leads outward once this boundary is crossed. While this may sound dramatic, it is also a natural consequence of how space-time behaves under extreme conditions. It is not a break in the rules, but an extension of them. Beyond the event horizon, our current understanding becomes limited. The equations that describe space-time suggest the presence of singularities, points of infinite density where known physics no longer applies. This brings us to the 54th truth. There are limits to what we can currently understand. Singularities represent the edges of our knowledge, where theories need to be expanded or reimagined. And yet, even without fully understanding these extremes, we can observe their effects from a distance. The motion of stars near black holes, the bending of light, and the emission of energy all provide clues about what is happening in these regions. Space-time is not only shaped by massive objects, but also by the overall energy content of the universe. The 55th truth is that the expansion of the universe is built into the fabric of space-time itself. It is not driven by galaxies moving apart through space, but by space itself stretching. This means that even empty regions of space are expanding, carrying everything with them. As this expansion continues, it affects how we perceive distances and time on a cosmic scale. Objects that are far enough away can appear to recede faster than the speed of light, not because they are moving through space that quickly, but because the space between us and them is expanding. This leads to a subtle but important realization. The 56th truth is that the speed of light limit applies to motion through space, not to the expansion of space itself. This distinction allows the universe to grow in ways that might otherwise seem impossible. As space-time stretches, it also influences how events are connected. The 57th truth is that causality, the relationship between cause and effect, is defined by the structure of space-time. Events can only influence each other if they are connected by paths that light or slower signals can travel. This creates a kind of cosmic order, ensuring that effects follow causes in a consistent way. And yet, at very small scales, the nature of reality becomes less certain. The 58th truth is that at the quantum level, space-time may behave in ways that challenge our classical understanding. Fluctuations, uncertainties, and probabilities replace the smooth, predictable structure we see at larger scales. Reconciling these two views, the smooth fabric of relativity and the probabilistic nature of quantum mechanics, remains one of the biggest challenges in physics. Some theories suggest that space-time itself could emerge from more fundamental components, perhaps arising from quantum interactions. Others propose additional dimensions beyond the three of space and one of time that we experience. This leads to the 59th truth. The universe may have more dimensions than we can perceive. These extra dimensions, if they exist, could be compact and hidden, influencing the behavior of particles and forces in subtle ways. While these ideas remain theoretical, they offer glimpses into a deeper structure that might underlie everything we observed. As we move from the smallest scales back to the largest, space-time reveals another remarkable feature. The 60th truth is that the universe has no known center or edge. From any point within it, the expansion appears the same. This uniformity suggests that the universe, on large scales, is both homogeneous and isotropic, essentially the same in all directions. This idea can feel counterintuitive, but it reflects the simplicity underlying the universe's vast complexity. No location is special, and no direction is preferred. Everything unfolds within the same expanding fabric. And as this realization settles in, the sense of scale begins to soften. The universe is not something happening far away. It is something happening everywhere, including here. Every moment you experience is part of this continuous flow through space-time. Every second is a movement along its fabric, guided by the same rules that govern galaxies and stars. As your thoughts drift across these ideas, there is a quiet rhythm to them. Curves and motion, expansion and connection, time and stillness, all woven together into a single, seamless whole. That it is not necessary to hold every detail in your mind. Instead, you can simply rest in the feeling of it, a universe that is structured, yet fluid, vast, yet connected. And as the mind begins to slow, following the gentle curves of space-time itself, there is a sense of being carried along, not needing to direct or control, but simply moving with the natural flow of existence. A fabric that stretches without end, holding everything, including you, in its quiet, steady embrace. Chapter 4. Stars that live, burn, and die. As the universe continued its slow unfolding, stars became the quiet engines of transformation. They appeared not as sudden bursts of brilliance, but as natural outcomes of gravity's patient work, gathering clouds of gas into luminous spheres that would shape the fate of everything around them. Each star carries within it a story, a beginning, a life of steady burning, and an ending that returns its material back to the cosmos. If you imagine drifting through a calm region of space, far from the glow of galaxies, you might come across vast clouds of gas and dust, barely visible, stretching across light years. These clouds, known as nebulae, are where stars begin their lives. The 61st truth is that stars are born in cold, quiet regions of space. Despite their eventual brilliance, their origins are gentle, forming within clouds that are often colder than the emptiness surrounding them. Within these clouds, gravity slowly pulls particles together. It is not a dramatic collapse at first, but a gradual gathering, as if the universe itself is taking a slow breath inward. Over time, certain regions become denser than others, and these regions begin to attract even more matter. The 62nd truth is that star formation begins with imbalance. A slight increase in density leads to stronger gravitational pull, which leads to further accumulation, a self-reinforcing process that continues until a core begins to form. As this core grows, it heats up. The energy from collapsing material raises the temperature higher and higher, creating what is known as a protostar. At this stage, the object is not yet a true star, but it is on its way. The 63rd truth is that stars spend a significant portion of their early existence as protostars, slowly gathering mass and building the conditions necessary for nuclear fusion. This phase can last hundreds of thousands to millions of years. Eventually, the temperature and pressure at the core become intense enough to ignite fusion. Hydrogen nuclei begin to combine, forming helium and releasing energy in the process. This marks the birth of a true star. The 64th truth is that a star's life is defined by a balance between gravity and fusion. Gravity pulls inward, trying to collapse the star, while fusion pushes outward, creating pressure that holds the star stable. As long as this balance exists, the star remains in a steady state. This phase, known as the main sequence, is the longest period in a star's life. Our own sun is currently in this stage, quietly converting hydrogen into helium, releasing light and heat that sustain life on Earth. But not all stars are the same. The 65th truth is that a star's mass determines its entire life cycle. Smaller stars burn slowly and can last for tens or even hundreds of billions of years, while massive stars burn their fuel quickly and live much shorter lives. Massive stars shine brighter, hotter, and more intensely. Their energy output is enormous, but it comes at a cost. They consume their fuel rapidly, moving through their life stages much faster than smaller stars. As a star continues to burn hydrogen in its core, that fuel gradually becomes depleted. When the hydrogen runs low, the balance between gravity and fusion begins to shift. The 66th truth is that stars evolve when their fuel changes. As hydrogen is used up, the core contracts under gravity, increasing temperature and pressure. This allows new types of fusion to occur, depending on the star's mass. In stars like our Sun, the core begins to fuse helium into heavier elements like carbon and oxygen. Meanwhile, the outer layers expand dramatically, turning the star into a red giant. These red giants can grow so large that they engulf nearby planets. If our Sun were to enter this phase today, it could expand beyond the orbit of Earth. The 67th truth is that stars change size dramatically over their lifetimes. What begins as a compact, stable object can expand into something enormous, reshaping its surrounding environment. In more massive stars, the process continues further. They can fuse heavier elements in successive stages, forming layers within their cores like an onion, with each layer producing a different element. Eventually, this process leads to the formation of iron. And here, something important happens. The 68th truth is that iron cannot release energy through fusion in the same way lighter elements can. Once a star's core is primarily iron, fusion can no longer support the star against gravity. At this point, the balance is lost. Gravity takes over, and the core collapses rapidly. What follows is one of the most powerful events in the universe, a supernova explosion. This explosion releases an enormous amount of energy, briefly outshining entire galaxies. It also creates and disperses heavy elements, including gold, uranium, and many others. The 69th truth is that the most dramatic endings in the universe are also beginnings. Supernovae spread the elements necessary for planets and life, enriching the cosmos with new possibilities. After the explosion, what remains depends on the original mass of the star. Some stars leave behind dense cores known as neutron stars, while others collapse further into black holes. Even smaller stars, like our Sun, have their own quieter endings. The 70th truth is that not all stars end in explosions. Stars with lower mass shed their outer layers gently, creating beautiful structures known as planetary nebulae, while their cores remain as white dwarfs, small, dense remnants that slowly cool over time. And as you imagine these cycles, birth, balance, transformation, and release, there is a quiet rhythm that becomes apparent. Stars are not static objects, but processes unfolding over immense spans of time. They gather, they shine, they change, and they return their material to the universe, where it can be used again. In this way, stars are not just distant points of light. They are part of an ongoing cycle that connects everything, from the earliest moments of the universe to the present. And as this thought settles in, there is something deeply calming about it. The universe does not waste anything. It reuses, reshapes, and renews over and over again. The light from a star may travel for millions or billions of years, eventually reaching distant worlds, carrying with it a quiet story of transformation. And as you follow that light in your mind, drifting through space, moving from one star to another, there is a gentle sense of continuity, a feeling that everything is part of a larger, ongoing process. A process that unfolds without hurry, without noise, guided by simple rules that create endless variation. And as your thoughts begin to slow, carried by the steady rhythm of these cosmic cycles, the glow of distant stars becomes softer, more distant, like a quiet presence in the background, guiding you gently toward rest. As the life cycles of stars continue to unfold across the universe, their endings reveal some of the most fascinating and powerful transformations in all of cosmic history. What may seem like destruction at first is often a transition, a quiet passing of energy and matter into new forms, continuing the endless rhythm that defines the universe. When a star like our Sun approaches the end of its life, it does not collapse violently. Instead, it begins to shed its outer layers in a slow and graceful process. These layers drift outward, forming glowing shells of gas that expand into space over thousands of years. The 71st truth is that planetary nebulae are among the most delicate structures in the universe. Despite their name, they have nothing to do with planets. They are simply the outer layers of dying stars, illuminated by the remaining hot core at the center. These glowing shells can take on intricate shapes, rings, spirals, and even patterns that resemble flowers. Their beauty is a reminder that even endings can be gentle and visually stunning. The center of these nebulae remains a white dwarf, a dense core composed mostly of carbon and oxygen. It no longer produces energy through fusion, but it retains immense heat from its earlier life. The 72nd truth is that white dwarfs are incredibly dense. A single teaspoon of white dwarf material would weigh tons on Earth. And yet, despite this density, they are relatively small, often similar in size to our planet. Over time, these white dwarfs slowly cool and fade, eventually becoming cold, dark remnants. This process takes billions, even trillions of years, far longer than the current age of the universe. But not all stars end so quietly. For more massive stars, the story becomes more intense. After a supernova explosion, the core that remains can collapse into a neutron star, one of the densest objects known. The 73rd truth is that neutron stars are made almost entirely of neutrons. Under the immense pressure of collapse, protons and electrons combine, creating a compact object with extraordinary properties. These stars are incredibly small, often only about 20 kilometers across, yet they can contain more mass than the Sun. Their gravity is so strong that it dramatically affects the space-time around them. Some neutron stars rotate rapidly, emitting beams of radiation from their magnetic poles. As they spin, these beams sweep across space like lighthouse beams, creating what we observe as pulsars. The 74th truth is that pulsars are among the most precise natural clocks in the universe. Their rotation can be so regular that they rival atomic clocks in accuracy, ticking steadily over millions of years. In even more extreme cases, when the original star is massive enough, the collapse continues beyond the neutron star stage, forming a black hole. The 75th truth is that black holes represent the ultimate collapse of a star. Their gravity becomes so strong that nothing, not even light, can escape once it crosses the event horizon. And yet, black holes are not simply empty voids. They have structure, defined by properties like mass, spin, and charge. They interact with their surroundings, influencing nearby stars and gas. Material falling into a black hole does not disappear instantly. It often forms an accretion disk, a swirling disk of matter that heats up and emits intense radiation before crossing the event horizon. The 76th truth is that black holes can be among the brightest objects in the universe when actively feeding. The energy released by infalling matter can outshine entire galaxies. In some cases, black holes also produce powerful jets of energy that extend far beyond their host galaxies. These jets travel at nearly the speed of light, carrying energy across vast distances. As these extreme objects interact, they can also merge. When two neutron stars or black holes spiral toward each other and collide, they release gravitational waves, ripples in spacetime that travel outward. The 77th truth is that these cosmic collisions create some of the heaviest elements in the universe. Gold, platinum, and other rare elements are believed to form in these intense events, spreading through space to become part of future stars and planets. This means that even the rarest materials on Earth have origins tied to these distant, powerful events. As the remnants of stars continue to evolve, they influence future generations of stars. The gas and dust enriched by previous stars become the raw material for new star formation. The 78th truth is that the universe is a cycle of renewal. Each generation of stars builds upon the last, increasing the diversity of elements and structures over time. And within this cycle, there is a remarkable consistency. The same fundamental processes repeat across the universe, creating patterns that can be observed in galaxies billions of light years away. The 79th truth is that the laws governing stars are universal. Whether in a nearby galaxy or at the edge of the observable universe, stars form, evolve, and die in similar ways. This universality allows scientists to study distant stars and understand processes that cannot be observed directly in our own region. And yet, despite all this activity, the universe remains calm on the largest scales. Stars may explode, collapse, or merge, but these events are spread across such vast distances that the overall rhythm remains gentle. The 80th truth is that cosmic violence is balanced by cosmic scale. Even the most energetic events become part of a larger, steady pattern when viewed across the entire universe. As you imagine these cycles. Stars forming in quiet clouds, burning steadily for millions or billions of years, and then transforming into something new. There is a sense of continuity that emerges. Nothing is truly lost. Matter changes form, energy shifts, structures evolve, but the process continues. And within that process, everything is connected. The atoms in your body were once part of stars that lived long before the sun existed. Those stars themselves were formed from even earlier generations, tracing a chain that reaches back to the beginning of the universe. As this thought gently settles, there is something deeply calming about it. You are not separate from the cosmos. You are part of its ongoing story, a story written in light, shaped by gravity, and carried forward through time. And as your mind follows this story, moving from one star to another, from one transformation to the next, the vastness of it all begins to feel less overwhelming and more like a quiet rhythm, a rhythm that continues endlessly softly, guiding everything toward its next form. And as that rhythm slows in your awareness, the glow of distant stars becomes softer still, like a fading light at the edge of thought, gently inviting rest. Chapter 5. Black holes and the edge of reality. There are places in the universe where the familiar rules begin to soften, where gravity becomes so strong that even the structure of space and time bends inward, quietly folding into something we are still trying to understand. These places are not chaotic in the way we might imagine. They are precise, governed by the same laws as everything else, yet taken to their most extreme limits. These are black holes. If you were to observe one from a safe distance, you would not see a hole in the traditional sense. Instead, you would notice a region of space where light behaves strangely, where stars appear distorted, and where a dark boundary marks a point of no return. The 81st truth is that a black hole is not an object in space, but a region of space where gravity has become overwhelmingly strong. It is defined not by a surface, but by a boundary known as the event horizon. This boundary is subtle. There is no physical wall, no sudden barrier you could touch. And yet, once crossed, there is no path that leads back out. The 82nd truth is that the event horizon marks the limit of escape. Anything that crosses it, matter, light, or information, becomes hidden from the rest of the universe. From the outside, objects falling toward a black hole appear to slow down as they approach this boundary. Their light becomes redder and dimmer, gradually fading from view. This leads to the 83rd truth. Time appears to slow near a black hole. To a distant observer, an object never quite crosses the event horizon. Instead, it seems to linger, fading away over time. But from the perspective of the object itself, the experience is different. It would cross the event horizon without noticing anything unusual at that exact moment. The difference lies in how time is experienced in different regions of space-time. Black holes form when massive stars collapse under their own gravity, compressing their mass into an extremely small region. The 84th truth is that black holes can vary greatly in size. Some are only a few times more massive than the Sun, while others, supermassive black holes, can contain millions or even billions of times the Sun's mass. These supermassive black holes are found at the centers of most galaxies, including our OWNAT. The heart of the Milky Way lies a supermassive black hole known as Sagittarius A star. It quietly influences the motion of stars orbiting nearby, shaping the structure of the galaxy over long periods of time. Despite their name, black holes are not empty. They contain mass, and that mass determines how they interact with the surrounding universe. The 85th truth is that black holes can grow over time. As they pull in gas, dust, and even entire stars, their mass increases, expanding the size of their event horizons. Before matter crosses into a black hole, it often forms an accretion disk, a swirling, flattened structure of material spiraling inward. As this material accelerates, it heats up, emitting intense radiation. This makes the regions around active black holes some of the brightest in the universe. The 86th truth is that black holes are often surrounded by some of the most energetic environments in existence. The light emitted from their accretion disks can travel across billions of light years, allowing us to detect them from great distances. In some cases, black holes also produce powerful jets of particles that shoot out from their poles at nearly the speed of light. These jets can extend far beyond their host galaxies, carrying energy across vast regions of space. Yet, for all their activity, the interior of a black hole remains hidden. What happens beyond the event horizon is still unknown. The 87th truth is that black holes challenge our understanding of reality. The equations that describe them suggest the existence of singularities, points where density becomes infinite and the known laws of physics break down. These singularities represent a boundary not just in space, but in knowledge. They are places where our current theories are no longer sufficient, hinting at deeper principles yet to be discovered. And yet, even without seeing inside a black hole, we can study their effects. The motion of nearby stars, the behavior of light, and the emission of energy all provide clues. The 88th truth is that we can see black holes indirectly. By observing how they influence their surroundings, scientists have been able to map their presence and properties with remarkable accuracy. In fact, the first image of a black hole's shadow was captured in 2019, revealing a glowing ring of light surrounding a dark center, a visual confirmation of predictions made decades earlier. But perhaps one of the most intriguing aspects of black holes lies not in their size or power, but in how they relate to information. The 89th truth is that information may never truly be lost, even in a black hole. This idea has led to deep questions about how information is stored and preserved in the universe, and whether it can ever be completely erased. This remains an active area of research, connecting black holes to the fundamental nature of reality itself. And as we approach the edge of what we can understand, there is a quiet sense of mystery that begins to settle in. Black holes are not chaotic voids, but precise, structured regions where the familiar rules of the universe reach their limits. They are not separate from the rest of the cosmos, but part of the same fabric, shaped by the same principles, yet revealing them in extreme ways. The 90th truth is that the universe contains boundaries not just of space, but of knowledge. And within those boundaries lies the potential for deeper understanding. As you imagine these distant regions, silent, powerful, and hidden, there is something strangely calming about them. They exist without urgency, without noise, simply following the natural flow of space-time. And as your thoughts drift closer to that boundary, not crossing it, but observing from afar, there is a gentle sense of perspective, a reminder that the universe is vast, that it holds mysteries beyond our current understanding. and that not everything needs to be fully known to be appreciated. The edge of reality is not something to fear, but something to quietly wonder about, like a distant horizon, always present, always inviting curiosity. And as that curiosity softens into calm, the mind begins to slow once more, carried gently by the quiet presence of these unseen depths, where space folds inward and time itself begins to fade. As we continue to drift along the quiet edges of black holes, the mystery deepens, not in a loud or overwhelming way, but in a slow, unfolding sense of wonder. These regions of space do not simply challenge our understanding of gravity. They gently pull at the very concepts of time, information, and reality itself. From a distance, a black hole appears calm. It does not glow on its own, nor does it actively reach out. And yet, its presence shapes everything nearby. Stars orbit it, light bends around it, and matter spirals inward, gradually disappearing from view. The 91st truth is that black holes are not cosmic vacuum cleaners. They do not pull in everything around them indiscriminately. Objects must come very close before being captured. From afar, their gravitational pull behaves just like that of any other object with the same mass. This means that if our sun were somehow replaced by a black hole of equal mass, the planets would continue orbiting as they do now, only without the light and warmth we depend on. But as matter moves closer, the effects become more extreme. Tidal forces begin to stretch objects, pulling them apart in a process sometimes described as spaghettification. While the term sounds unusual, the underlying physics is precise and predictable. The 92nd truth is that gravity can vary significantly over short distances near a black hole. The difference in gravitational pull between one part of an object and another can become so large that it stretches and compresses matter. As this process unfolds, the material becomes part of the accretion disk, gradually heating and radiating energy before crossing the event horizon. But what happens after that remains uncertain. One of the most intriguing ideas related to black holes was proposed by Stephen Hawking, who suggested that black holes are not entirely black. Instead, they emit a faint form of radiation now known as Hawking radiation. The 93rd truth is that black holes can slowly lose mass over time. Through quantum effects near the event horizon, particles can escape, causing the black hole to gradually shrink. This process is incredibly slow for large black holes, taking far longer than the current age of the universe. But it introduces a surprising idea that black holes are not permanent. Over unimaginable spans of time, they may eventually evaporate completely. This leads to one of the most profound questions in physics: that if a black hole disappears, what happens to the information contained within everything it absorbed? The 94th truth is that the fate of information in black holes remains an open question. According to the laws of quantum mechanics, information should never be destroyed. But classical descriptions of black holes suggest that it could be lost. This apparent contradiction is known as the black hole information paradox, and it continues to drive research into the fundamental nature of reality. Some theories propose that information is encoded on the surface of the event horizon, while others suggest it may be preserved in subtle correlations within Hawking radiation. Though the answer is not yet fully understood, it hints at a deeper connection between gravity, quantum mechanics, and information. As we consider these ideas, the nature of time itself begins to feel less fixed. The 95th truth is that near a black hole, time can stretch to extraordinary degrees. From the perspective of a distant observer, processes near the event horizon appear to slow almost to a stop. Entire sequences of events can seem frozen in time. Yet for an object falling inward, time continues as normal, at least until it reaches regions where our current theories no longer apply. This duality, two different experiences of time depending on perspective, reflects the deeper flexibility of space-time itself. Black holes also offer a unique environment for testing the limits of physics. The 96th truth is that black holes act as natural laboratories for extreme conditions. Temperatures, densities, and gravitational forces reach levels that cannot be replicated on Earth, allowing scientists to explore how the laws of physics behave under these conditions. Through observations and simulations, researchers continue to refine their understanding, uncovering new layers of complexity. Some theories even suggest that black holes could be connected to other regions of space-time. The 97th truth is that certain solutions to the equations of relativity allow for the possibility of wormholes, hypothetical tunnels connecting distant points in space and time. While there is no direct evidence that such structures exist, they remain an intriguing possibility. These ideas stretch the imagination, but they are grounded in the same mathematical framework that accurately describes many observed phenomena. As black holes interact and merge, they release bursts of gravitational waves that ripple through space-time. The 98th truth is that these ripples carry information about the most violent events in the universe. By detecting them, scientists can study collisions between black holes and neutron stars, gaining insight into their properties and behavior. These detections have opened a new way of observing the universe, not through light, but through the movement of space-time itself. And yet, for all their complexity, black holes remain part of the same quiet cosmic rhythm. They form from stars, grow over time, interact with their surroundings, and eventually may fade away. They are not anomalies, but natural outcomes of the universe's laws. The 99th truth is that even the most extreme objects follow the same underlying principles as everything else. Black holes do not break the rules, they reveal them more clearly. And as we reach the edge of this chapter, one final thought begins to settle in. The 100th truth is that the universe is not only vast and complex, but deeply consistent. From the smallest particles to the largest structures, the same patterns repeat, the same laws apply, and the same quiet processes continue. Black holes, with all their mystery, are not separate from this story. They are part of it, expressions of the same fabric of space-time that holds everything together. And as your mind lingers on this idea, the mystery begins to feel less like something distant and more like something gently present. A reminder that not all questions need immediate answers. Some can simply exist, quietly, like the black holes themselves, holding their secrets, shaping the universe, and waiting. And as that thought softens, the edges of understanding begin to blur into calm. The vastness of space becomes quieter, and the mind, following that stillness, begins to rest. Chapter 6. The strange behavior of time. Time feels simple when we move through our daily lives. It flows steadily, second by second, guiding routines, marking memories, and quietly carrying everything forward. And yet, when we step back and observe the universe on a larger scale, time reveals itself as something far more flexible, something that bends, stretches, and even slows depending on where you are and how you move. In the calm silence of space, far from the rhythms of clocks and calendars, time does not behave in the way we might expect. It is not a universal ticking mechanism shared equally by everything. Instead, it is deeply connected to motion, gravity, and the structure of space-time itself. The 101st truth is that time is not absolute. It does not pass at the same rate for everyone, everywhere. This idea, once difficult to imagine, became clear through the work of Albert Einstein, who showed that time depends on both speed and gravity. If two observers are moving differently or experiencing different gravitational conditions, they will measure time differently. Each will feel that their own time is normal while the other appears altered. This leads to the 102nd truth: motion changes time. The faster you move through space, the slower time passes for you relative to someone at rest. This effect is extremely small at everyday speeds, but it becomes significant as you approach the speed of light. In experiments, highly precise clocks placed on fast-moving aircraft or satellites have been shown to tick slightly slower than those on the ground. These differences, though tiny, are measurable and must be accounted for in systems like GPS, but motion is only part of the story. The 103rd truth is that gravity also affects time. In stronger gravitational fields, time moves more slowly. This means that time passes differently depending on how close you are to a massive object. Even on Earth, time at sea level moves slightly slower than time at higher altitudes. The difference is so small that we don't notice it, but it is real and measurable. Near extreme objects like black holes, this effect becomes dramatic. Time can slow to such an extent that, from a distant perspective, it appears almost frozen. The 104th truth is that time can stretch and compress depending on perspective. Two observers experiencing different conditions may disagree on how much time has passed, yet both are correct within their own frames of reference. This idea can feel unusual, but it reflects the deeper structure of reality. Time is not something separate from the universe. It is woven into it. As we consider this, another layer of complexity begins to emerge. The 105th truth is that there is no single present moment shared across the entire universe. What is happening now for one observer may be in the past or future for another, depending on their motion and position. This concept, known as relativity of simultaneity, suggests that time is not a universal flow but a series of local experiences. And yet, despite this flexibility, time still moves in a particular direction. The 106th truth is that time appears to have an arrow, a direction from past to future. We remember the past, but not the future. Processes unfold in one direction, creating a sense of progression. This arrow of time is closely related to the concept of entropy, a measure of disorder. The 107th truth is that entropy tends to increase over time. Systems naturally evolve from more ordered states to less ordered ones. This gradual increase gives time its direction, distinguishing the past from the future. For example, a glass can fall and shatter, increasing disorder, but the reverse process does not occur naturally. This asymmetry reflects the underlying flow of time. But even this direction is not as rigid as it might seem. The 108th truth is that at the smallest scales, the laws of physics are often time-symmetric. This means that many fundamental interactions could occur in reverse without violating physical laws. The arrow of time emerges not from these laws themselves, but from the overall behavior of large systems. As we explore further, time begins to feel less like a steady river and more like a landscape, something that can be shaped, curved, and experienced differently depending on where you are. The 109th truth is that time and space are deeply interconnected. They cannot be fully separated. Movement through one affects movement through the other, creating a unified structure that defines how events unfold. This connection allows for fascinating possibilities. For instance, if you were to travel at extremely high speeds, time for you would pass more slowly compared to those who remain at rest. You could, in a sense, move into the future relative to others. The 110th truth is that time travel into the future is not just theoretical, it is a natural consequence of relativity. While the effect is small at ordinary speeds, it becomes significant at speeds close to that of light. Astronauts aboard spacecraft experience this effect slightly, aging a tiny bit less than people on Earth. Over longer journeys at higher speeds, the difference would become more noticeable. However, traveling into the past presents far greater challenges. The structure of space-time does not easily allow for paths that loop backward in time. While certain theoretical solutions suggest it might be possible under extreme conditions, there is no evidence that such travel can occur. As we gently consider these ideas, the nature of time begins to feel less rigid, more fluid, more open to interpretation. It is not something that pushes us forward, but something we move through, influenced by where we are, how fast we travel, and how space itself is shaped around us. And as this realization settles in, there is something quietly comforting about it. Time is not something to race against, not something that needs to be controlled. It simply flows differently in different places, yet always in harmony with the structure of the universe. And as your thoughts drift along this gentle flow, moving through moments without urgency, the sense of time begins to soften, seconds feel less defined, thoughts slow, and the quiet rhythm of the universe becomes more present. A rhythm where time stretches, where moments expand, and where everything unfolds at its own natural pace. As we continue drifting through the quiet nature of time, it begins to feel less like a strict sequence of ticking moments and more like something shaped by perception, something experienced differently depending on awareness, memory, and motion. Time, as it turns out, is not only a physical phenomenon but also something deeply tied to how we observe and interpret the universe. The 111th truth is that time is closely linked to memory. What we call the past is not something we revisit physically, but something we reconstruct through stored information. Memory gives structure to time, allowing us to distinguish between what has happened and what is yet to come. Without memory, the sense of time would fade. Moments would exist, but they would not connect into a narrative. In this way, time is not just something that happens externally, it is something we experience internally. As we move forward, another subtle idea begins to emerge. The 112th truth is that the present moment is incredibly brief. It is not a fixed point that can be held onto, but a continuous transition between past and future. By the time we become aware of a moment, it has already passed. This fleeting nature gives time its gentle, flowing quality. It is always moving, never stopping, yet never rushing. And yet, the way we perceive this flow can change. The 113th truth is that perception of time can stretch or compress depending on attention. When we are focused and engaged, time may seem to pass quickly. When we are waiting or restless, it may feel slower. This variation does not change time itself, but it changes how we experience it. It adds a subjective layer to something that is already physically flexible. As we consider this, another layer unfolds, the relationship between time and causality. The 114th truth is that cause and effect rely on the structure of time. Events unfold in sequences, where one leads to another. This ordering gives meaning to actions and consequences. However, as we explored earlier, relativity shows that the ordering of events can differ depending on perspective. This suggests that causality, while consistent locally, is part of a broader and more flexible framework. And then comes a deeper question: does time truly flow, or is that just how we perceive it? The 115th truth is that some theories describe time as a dimension similar to space. In this view, past, present, and future may all exist simultaneously, like different locations along a path. This idea is sometimes referred to as the block universe, where time does not move but simply exists as a whole. Our experience of moving through time could then be a result of consciousness progressing along this dimension. While this concept is still debated, it offers a different way of imagining reality, one where time is not a river, but a landscape. As we move deeper into this perspective, the boundaries between past and future begin to soften. The 116th truth is that the distinction between past and future may not be as absolute as it seems. While we experience a clear direction, the underlying laws of physics do not always enforce that direction strictly. This raises questions about whether the flow of time is fundamental or whether it emerges from deeper processes. Meanwhile, on cosmic scales, time behaves in ways that stretch our imagination. The 117th truth is that the universe itself has a timeline, evolving from a hot, dense beginning to its current expanded state. This cosmic timeline provides a larger context for everything we observe. And yet, within that timeline, different regions of the universe can experience time differently, depending on gravity and motion. As the universe expands, time continues to move forward, but the rate at which structures evolve changes. Early in the universe, changes happened rapidly. Now, on large scales, things evolve more slowly. The 118th truth is that the pace of change in the universe is not constant. It slows as structures become larger and more stable. Stars take millions or billions of years to evolve. Galaxies change over even longer periods. And the universe itself unfolds over timescales that extend far beyond human comprehension. This slow pace contributes to the calm, steady rhythm that defines the cosmos. And as we consider these vast timescales, another idea begins to take shape. The 119th truth is that time connects everything across scales. From the brief flicker of a particle interaction to the slow evolution of galaxies, all processes unfold within the same framework. This connection creates a continuity that links the smallest and largest aspects of the universe. Finally, we arrive at a quiet reflection. The 120th truth is that time is not something separate from existence, it is part of it. It does not act upon the universe from the outside, but arises from the relationships between events, motion, and change. As you let this idea settle, time begins to feel less like something to measure and more like something to experience. It becomes a gentle flow, shaped by perception, influenced by motion, woven into the fabric of everything. And as your awareness softens, the boundaries between moments begin to blur. The past feels distant, the future feels quiet, and the present becomes a calm, continuous space. There is no need to hold on to any single moment. Each one arrives, exists briefly, and then gently gives way to the next. And within that flow, there is a sense of ease. A realization that time does not need to be controlled or resisted. It simply moves, carrying everything with it, including your thoughts, your awareness, and your sense of self. And as you drift along with it, the universe feels less like something vast and distant, and more like something steady and continuous. A quiet unfolding, where time stretches softly, and everything moves at its own natural pace. Chapter 7. Galaxies drifting in eternal silence. If you could step far beyond the boundaries of our solar system, beyond the familiar glow of nearby stars, and continue drifting outward into the deeper reaches of space, you would begin to notice something extraordinary. The universe is not scattered randomly. It is arranged quietly, patiently, into vast collections of stars known as galaxies, each one moving slowly through the fabric of space-time, like islands in an endless ocean. From a distance, galaxies appear serene. They do not rush or collide in chaotic motion. Instead, they drift, guided by gravity, tracing paths that take millions or billions of years to complete. Their movements are so slow, so steady, that they feel almost still. The 121st truth is that galaxies are the fundamental building blocks of the universe's large-scale structure. Each galaxy contains millions to trillions of stars, along with gas, dust, and dark matter, all bound together by gravity. Our own home exists within one such galaxy, the Milky Way, a vast spiral structure that stretches across about 100,000 light-years. Within it are hundreds of billions of stars, each with its own story, its own planets, and its own quiet motion. But the Milky Way is only one among many. The 122nd truth is that there are likely hundreds of billions, or even trillions, of galaxies in the observable universe. Each one drifts through space, separated by immense distances, yet all part of the same expanding cosmic fabric. Galaxies come in different shapes and sizes. Some are spiral, with graceful arms winding outward from a central core. Others are elliptical, appearing more rounded and diffuse. Some are irregular, lacking a defined structure, shaped by past interactions and collisions. The 123rd truth is that a galaxy's shape tells the story of its history. Collisions, mergers, and internal dynamics all influence how a galaxy appears over time. Spiral galaxies, like the Milky Way, often have ongoing star formation with bright, young stars lighting up their arms. Elliptical galaxies, on the other hand, tend to contain older stars and less active star formation. And yet, despite their differences, all galaxies share a common feature: they are constantly moving. The 124th truth is that galaxies are not stationary. They orbit within clusters, move along filaments of the cosmic web, and drift apart as the universe expands. Some galaxies exist in groups, bound together by gravity. The Milky Way, for example, is part of the local group, which includes nearby galaxies like the Andromeda Galaxy. These galaxies are not fixed in place. They interact, influence each other, and sometimes even merge. The 125th truth is that galaxy collisions are common over cosmic timescales. While the distances between stars are so vast that direct collisions are rare, the overall structures of galaxies can merge, reshaping both systems. In fact, the Milky Way and Andromeda are expected to merge in several billion years, forming a new, larger galaxy. This process will unfold slowly, over millions of years, with stars shifting into new orbits, creating new patterns in the sky. Despite the scale of these events, they are not violent in the way we might imagine. They are gradual, almost graceful, guided by gravity's steady influence. As galaxies move, they also rotate. The 126th truth is that galaxies spin, with stars orbiting their centers over vast periods of time. In the Milky Way, it takes our Sun about 225 million years to complete a single orbit around the galactic center. This motion is so slow that, within a human lifetime, it is almost imperceptible. And yet, it is constant, carrying us through space as part of a much larger system. At the centers of most galaxies lies a supermassive black hole, quietly influencing the motion of surrounding stars. The 127th truth is that these central black holes help regulate the behavior of galaxies. While they do not control everything, their presence affects star formation, gas movement, and overall structure. And yet, beyond individual galaxies, there is an even larger pattern. The 128th truth is that galaxies are arranged in a vast cosmic web. They are not evenly distributed, but connected through filaments of matter, forming clusters and superclusters separated by enormous voids. This structure resembles a network, a delicate balance of density and emptiness, stretching across the observable universe. Within this web, galaxies drift slowly along gravitational pathways, moving toward denser regions while the universe itself expands. The 129th truth is that the space between galaxies is immense. Even the closest galaxies are separated by distances so vast that light takes millions of years to travel between them. And yet, despite the separation, everything remains connected through gravity and the expansion of space-time. As you imagine these galaxies, countless, drifting, glowing softly in the darkness, there is a sense of quiet motion that emerges. They are not rushing. They are not colliding constantly. They are simply moving slowly, steadily, following paths shaped by forces that have been present since the beginning. The 130th truth is that the universe evolves through slow, continuous motion. The largest structures change over billions of years, far beyond the pace of human experience. And within that slow motion, there is a certain calm. Galaxies drift in silence. Stars orbit quietly. Light travels across unimaginable distances without interruption. And as your thoughts follow this movement, drifting from one galaxy to another, From one cluster to the next, there is a gentle sense of scale, a feeling of being part of something vast yet steady. Nothing is rushing. Nothing is out of place. Everything moves according to the same quiet rhythm, a rhythm that stretches across space and time, carrying galaxies along their paths and holding them in a delicate, endless balance. And as that rhythm becomes softer in your awareness, the vastness of the universe begins to feel less overwhelming and more like a calm, steady presence, a silent drift across an endless cosmic ocean, where galaxies move like distant lights, glowing softly and guiding the mind toward rest. As galaxies continue their slow and silent motion across the universe, their stories stretch far beyond what we can observe in a single lifetime. Each one carries a history shaped by billions of years, a quiet accumulation of motion, interaction, and transformation. And yet, even as they drift, there is a sense that they are part of something even larger, something that unfolds gently across time. When galaxies move within groups and clusters, their interactions become more noticeable. Gravity draws them toward one another, guiding their paths in slow arcs that can eventually lead to close encounters. The 131st truth is that galaxy interactions are common in dense regions of the universe. In clusters, where many galaxies exist relatively close together, their gravitational influence becomes more pronounced. As galaxies pass near each other, their shapes can become distorted. Spiral arms may stretch and twist, streams of stars can be pulled outward, and gas clouds may be compressed, triggering bursts of star formation. These events do not happen suddenly. They unfold over millions of years, gradually reshaping the galaxies involved. The 132nd truth is that galaxy encounters can stimulate new creation. When gas clouds are compressed during interactions, they can collapse more easily, forming new stars at an increased rate. These periods, sometimes called starbursts, fill galaxies with bright, young stars that shine intensely for a relatively short time. As interactions continue, some galaxies eventually merge completely. Their structures blend together, forming a single, larger galaxy with a new shape and composition. The 133rd truth is that mergers are a key part of galaxy evolution. Over time, many galaxies grow by combining with others, building larger and more complex systems. These mergers often lead to the formation of elliptical galaxies, where the ordered structure of spiral arms is replaced by a more uniform distribution of stars. And yet, even after such dramatic transformations, the overall motion remains calm. Stars within merging galaxies rarely collide directly due to the vast distances between them. Instead, they shift into new orbits, gradually settling into a new equilibrium. The 134th truth is that even large-scale cosmic events are governed by balance. Gravity redistributes motion and energy, guiding systems toward stability over time. Beyond individual clusters, galaxies continue to drift apart as the universe expands. This expansion stretches the distances between clusters, gradually isolating them from one another. The 135th truth is that cosmic expansion leads to increasing isolation. Over time, galaxies outside our local group will move so far away that their light will no longer reach us. This means that, in the distant future, observers within a galaxy may only see their own local group, unaware of the vast universe beyond. And yet, within these local regions, motion continues. The Milky Way and the Andromeda Galaxy are gradually moving toward each other. Their future merger will reshape both galaxies, creating a new system sometimes referred to as Milkomeda. The 136th truth is that galaxies can have long-term destinies shaped by gravity. While expansion separates distant galaxies, local interactions continue to bring some together. As galaxies age, their internal activity also changes. Star formation slows as available gas is used up or dispersed. The 137th truth is that galaxies gradually become quieter over time. With fewer new stars forming, they become dominated by older, cooler stars, giving them a softer, more subdued appearance. This shift reflects a broader trend in the universe, a gradual move from active formation to slower evolution. And yet, even in this quieter phase, galaxies remain dynamic systems. Stars continue to orbit, remnants of past events persist, and subtle interactions still occur. The 138th truth is that change in the universe never truly stops. It simply slows, becoming more gradual and less intense over time. As we look even further ahead, the effects of expansion become more dominant. Clusters of galaxies remain bound together by gravity, but the space between clusters continues to grow. The 139th truth is that the large-scale structure of the universe will become more fragmented. Isolated clusters will drift apart, leaving vast regions of empty space between them. Within these isolated clusters, galaxies will continue their slow evolution, eventually merging or settling into stable configurations. And beyond that, time stretches into scales that are difficult to imagine. The 140th truth is that galaxies are temporary structures on cosmic timescales. While they exist for billions of years, they are part of a larger process that continues to evolve. As stars age and fade, and as fewer new stars form, galaxies will gradually dim. And yet, even as they dim, they remain part of the same quiet rhythm that has guided the universe since its beginning. As you imagine these distant galaxies, merging, drifting, evolving, there is a sense of continuity that emerges. Nothing is static. Nothing is truly permanent. But nothing is rushed either. Everything unfolds slowly, gently, guided by forces that operate over vast stretches of time. And within that slow unfolding, there is a kind of peace. Galaxies do not resist their motion. They follow it. Stars do not rush their lifetimes. They burn steadily, and space itself continues to expand, carrying everything along without urgency. As your thoughts drift through these distant systems, moving from one galaxy to another, from one cluster to the next, the vastness begins to feel less overwhelming and more like a quiet ocean, an ocean where galaxies are like distant lights, moving slowly, softly glowing, and gradually shifting into new forms. And as that image settles in, the motion becomes calmer, the distances feel softer, and the mind begins to follow that same slow rhythm, drifting gently through a universe that never hurries and never needs to. Chapter 8. The Unseen Universe, Dark Matter and Dark Energy. As we drift further into the quiet depths of the universe, something subtle begins to emerge. A realization that what we can see, the stars, the galaxies, the glowing clouds of gas, is only a small fraction of what truly exists. Beneath the visible beauty lies something hidden, something that does not shine, does not reflect light, and yet quietly shapes the structure of everything. The 141st truth is that most of the universe is invisible. The stars and galaxies we observe make up only a small portion of the total content of the cosmos. The majority exists in forms we cannot directly detect. This unseen presence reveals itself not through light, but through its influence. That as scientists studied the motion of galaxies, they noticed something unexpected. Stars at the outer edges of galaxies were moving faster than they should be, based on the visible mass alone. According to the laws of gravity, these stars should have been moving more slowly or even drifting away. But they were not. The 142nd truth is that there must be additional mass in galaxies that we cannot see. This hidden mass provides the extra gravitational pull needed to hold galaxies together. This mysterious substance was given a name: dark matter. Dark matter does not emit light, absorb light, or reflect light. It does not interact with electromagnetic forces in the way ordinary matter does. And yet, its presence is essential. The 143rd truth is that dark matter acts as a gravitational framework for the universe. It forms invisible halos around galaxies, providing the structure that allows them to form and remain stable. Without dark matter, galaxies as we know them would not exist. The visible matter alone would not be enough to hold them together. As researchers continued to study large-scale structures, they found that dark matter plays a role not just in individual galaxies, but in the entire cosmic web. The 144th truth is that dark matter helps shape the large-scale structure of the universe. It forms the scaffolding along which galaxies and clusters are distributed, guiding their formation over billions of years. In this sense, dark matter is like an unseen architecture, a framework that supports everything we can observe. And yet, despite its importance, its true nature remains unknown. The 145th truth is that dark matter has not yet been directly detected. Scientists have proposed various candidates, such as weakly interacting particles, but none have been confirmed. This makes dark matter one of the most intriguing mysteries in modern science, something we know must exist, but cannot yet fully understand as we consider this invisible presence. Another, even more mysterious component comes into view. While dark matter pulls things together through gravity, something else appears to be pushing the universe apart. The 146th truth is that the expansion of the universe is accelerating. Galaxies are not just moving away from each other, they are doing so at an increasing rate. This discovery was unexpected. For a long time, scientists assumed that gravity would slow the expansion over time. But observations revealed the opposite. To explain this acceleration, a new concept was introduced: dark energy. The 147th truth is that dark energy is the dominant component of the universe. It makes up the majority of its total energy content, driving the expansion of space itself. Unlike dark matter, which pulls, dark energy appears to push, stretching the fabric of space-time and increasing the distance between galaxies. And yet, like dark matter, its nature remains unknown. The 148th truth is that dark energy may be a property of space itself. Some theories suggest that even empty space contains a small amount of energy, which becomes significant when considered across the vastness of the universe. This energy does not dilute as space expands. Instead, it remains constant, causing the expansion to accelerate over time. As space stretches, galaxies drift farther apart, and the large-scale structure of the universe becomes more pronounced. The 149th truth is that the unseen components of the universe shape its destiny. Dark matter determines how structures form, while dark energy influences how they evolve and separate. Together, they define the past, present, and future of the cosmos. And yet, despite their importance, both remain hidden from direct observation. The 150th truth is that the universe is mostly made of things we do not yet understand. What we see, stars, planets, light, is only a small part of a much larger, more mysterious whole. As you imagine this unseen universe, there is something quietly humbling about it, a realization that even with all we have discovered, there is still so much that remains unknown. But this unknown is not chaotic or unsettling. It is calm, consistent, following the same underlying rules that govern everything else. Dark matter holds galaxies together silently. Dark energy stretches space gently, steadily, without interruption, and together, they create a universe that is both visible and invisible, known and unknown. Simple and deeply complex at the same time. As your thoughts drift through this hidden structure, moving beyond what can be seen, there is a sense of depth that begins to form, that a universe layered not just in space, but in understanding. And as that awareness softens, The need to fully grasp everything begins to fade. It becomes enough to simply observe, to sense the quiet presence of these unseen forces, and to rest within the knowledge that the universe continues to unfold, whether we fully understand it or not. A vast, invisible framework, holding everything gently in place, guiding motion, shaping destiny, all without ever being seen. As we continue drifting through the unseen layers of the universe, the presence of dark matter and dark energy begins to feel less like an absence and more like a quiet foundation. These invisible components do not announce themselves with light or sound, yet their influence is everywhere, shaping motion, guiding structure, and gently determining how the universe evolves. Even though dark matter cannot be seen directly, its effects can be mapped through careful observation. One of the most subtle ways it reveals itself is through the bending of light. The 151st truth is that dark matter can be detected through gravitational lensing. When light from distant galaxies passes through regions filled with dark matter, its path bends, creating distortions that can be measured. These distortions act like fingerprints, allowing scientists to trace where dark matter is located, even though it remains invisible. And this way, we begin to see the unseen, not through direct observation, but through the quiet influence it has on everything around it. As these maps become more detailed, they reveal that dark matter is not evenly distributed. The 152nd truth is that dark matter forms halos around galaxies and clusters. These halos extend far beyond the visible edges, surrounding galaxies in vast, invisible spheres of gravitational influence. Within these halos, galaxies form and evolve, held together by forces that cannot be directly observed. And yet, despite its gravitational presence, dark matter behaves differently from ordinary matter. The 153rd truth is that dark matter does not interact through light or electromagnetic forces. It passes through ordinary matter almost entirely unaffected, making it incredibly difficult to detect using traditional methods. This has led scientists to design highly sensitive experiments deep underground, shielded from interference, in hopes of capturing rare interactions between dark matter particles and ordinary matter. As so far, these experiments have not provided definitive answers. And so, the mystery remains. As we shift our attention back to dark energy, the sense of mystery deepens even further. Unlike dark matter, which pulls, dark energy appears to push, driving the expansion of the universe at an accelerating rate. The 154th truth is that dark energy becomes more influential over time. As the universe expands and matter becomes more spread out, the relative effect of dark energy increases, gradually dominating the large-scale behavior of the cosmos. This means that in the distant future, expansion will continue to accelerate, stretching space more and more. Galaxies that are not gravitationally bound to us will drift farther away, eventually moving beyond the range of observation. The 155th truth is that the universe is becoming increasingly empty on large scales. Over time, distant galaxies will fade from view, leaving only local structures visible. This does not happen suddenly. It is a slow, steady process unfolding over billions of years. And yet, even as the universe expands, local systems remain intact. Galaxies, star systems, and planets continue their motion, bound together by gravity, unaffected by expansion on smaller scales. The 156th truth is that expansion operates differently at different scales. While space between galaxies grows, gravitationally bound systems remain stable, creating a layered structure of motion. As scientists attempt to understand dark energy, several possibilities have been proposed. The 157th truth is that dark energy may not be constant. Some theories suggest it could change over time, altering the rate of expansion and leading to different possible futures for the universe. In one scenario, expansion continues indefinitely, gradually cooling and dimming the universe. In another, dark energy could grow stronger, eventually overcoming all forces, leading to a dramatic end sometimes called the Big Rip. While these ideas remain theoretical, they highlight the importance of understanding this unseen force. As we reflect on these possibilities, another quiet realization begins to form. The 158th truth is that uncertainty is a natural part of scientific discovery. Not knowing is not a limitation, but an invitation, a space where new ideas can emerge. The universe does not reveal everything at once. It unfolds gradually, offering clues that guide understanding step by step. And in this process, mystery is not something to be eliminated, but something to be explored. As we consider the unseen universe as a whole, it becomes clear that what we cannot see is just as important as what we can. The 159th truth is that visibility does not determine significance. The most influential components of the universe are often the ones that remain hidden. Dark matter holds galaxies together. Dark energy shapes the expansion of space. And together, they define the large-scale behavior of the cosmos. Finally, we arrive at a quiet, grounding thought. The 160th truth is that the universe is far more than it appears. Beneath the visible layer lies a deeper structure, one that operates silently, consistently, and without interruption. As this idea settles in, there is a sense of calm that follows, a universe that is not chaotic, but layered, not random, but structured. Even in its mysteries, and as your thoughts drift through this unseen framework, moving beyond light and into the quiet presence of invisible forces, the mind begins to slow once more. There is no need to fully understand everything. It is enough to know that something is there, shaping, guiding, and holding everything together, a hidden architecture vast and steady, extending beyond sight, yet always present. And as that presence softens into stillness, the universe feels quieter, deeper, more expansive, a place where even the unseen carries a gentle sense of order, inviting the mind to rest within its quiet mystery. Chapter 9. Cosmic mysteries that still haunt scientists. As we move deeper into the universe, beyond what is known and measured, we begin to encounter questions that remain open, quiet uncertainties that linger at the edges of understanding. These are not gaps in knowledge caused by a lack of effort, but natural frontiers, places where current theories reach their limits and gently give way to curiosity. The universe, for all its structure and consistency, still holds many mysteries. And rather than disrupting its calm, these mysteries add depth to it, like distant horizons that invite thought without demanding immediate answers. The 161st truth is that we still do not fully understand how the universe began. While the Big Bang model describes the early expansion with great accuracy, it does not explain what caused it or what, if anything, existed before. Some theories suggest a prior state, others propose cycles of expansion and contraction, and some indicate that the concept of before may not even apply. This leads to the 162nd truth. The beginning of time itself may be beyond our current ability to describe. If time emerged with the universe, then asking what came before it becomes a question without a clear meaning. As we move forward, another mystery comes into focus, one that exists at the smallest scales of reality. The 163rd truth is that we do not yet have a complete theory that unifies gravity with quantum mechanics. These two frameworks describe the universe in different ways, and while both are highly successful in their domains, they do not fully align. Gravity governs the large-scale structure of the universe, while quantum mechanics describes the behavior of particles at the smallest scales. Bringing these together into a single, unified theory remains one of the greatest challenges in physics, and within that challenge lies another question. The 164th truth is that space-time itself may not be fundamental. Some theories suggest it could emerge from deeper quantum processes, meaning that what we perceive as space and time might arise from something more basic. This idea shifts the perspective entirely, from viewing space-time as the foundation to seeing it as a result. As we continue, we encounter one of the most puzzling aspects of modern physics, the nature of consciousness and its relationship to the universe. The 165th truth is that we do not fully understand how consciousness arises from physical processes. While neuroscience explains many aspects of brain function, the subjective experience of awareness remains difficult to define scientifically. This raises subtle questions about observation, perception, and the role of the observer in understanding reality. In quantum mechanics, the act of observation can influence outcomes at very small scales. While this does not imply anything mystical, it highlights how measurement and interaction are deeply connected. The 166th truth is that observation plays a role in how we describe reality. At the quantum level, systems exist in multiple possible states until measured, at which point one outcome is realized. This behavior challenges classical intuitions and suggests that reality may not be fully determined until it is observed. And yet, even as we explore these ideas, the universe remains consistent. The laws that govern large-scale behavior continue to apply, providing a stable framework within which these uncertainties exist. Another mystery lies in the imbalance between matter and antimatter. The 167th truth is that the universe contains far more matter than antimatter. According to current theories, both should have been produced in equal amounts during the early universe. However, if that were the case, they would have annihilated each other completely, leaving behind only energy. The fact that matter remains suggests that some asymmetry occurred, a slight imbalance that allowed matter to persist. Understanding why this happened remains an open question. As we move outward, we encounter another profound uncertainty: the possibility of life beyond Earth. The 168th truth is that while the conditions for life appear to exist elsewhere in the universe, we have not yet found definitive evidence of extraterrestrial life. Given the vast number of stars and planets, it seems statistically likely that life could exist elsewhere. And yet, the universe remains quiet. This is sometimes referred to as the Fermi paradox. The question of why, if life is common, we have not yet observed clear signs of it. There are many possible explanations, ranging from the rarity of life to the vast distances involved, and within this question lies a deeper reflection. The 169th truth is that the universe may be filled with life, or it may be rare. At present, we simply do not know. This uncertainty does not diminish the universe. Instead, it adds a quiet sense of possibility. Finally, we arrive at another subtle mystery: the nature of reality itself. The 170th truth is that our understanding of reality is always evolving. What we consider fundamental today may be refined or expanded in the future as new discoveries are made. Science does not claim to have all the answers. It builds models, tests them, and adjusts them over time. And in this process, mystery is not something to eliminate, but something to explore. As you reflect on these questions, the beginning of the universe, the nature of time, the balance of matter, the possibility of life, there is a gentle sense of openness that emerges. The universe is not fully known, and that is part of its quiet beauty. It invites curiosity without urgency. It allows questions to exist without immediate answers. And as your thoughts drift among these mysteries, moving from one idea to another, there is no need to resolve them all. They can simply be there, like distant stars, softly present, adding depth to the vastness. And as that depth settles into calm, the mind begins to slow, resting not in certainty, but in quiet curiosity, where the unknown feels less like a gap and more like a gentle horizon. As we continue drifting along the quiet edges of understanding, the mysteries of the universe begin to feel less like problems to be solved and more like gentle invitations to explore. Each unanswered question opens another layer, revealing not confusion, but depth, a sense that reality extends further than our current understanding can reach. One of the most profound of these mysteries lies in the limits of knowledge itself. The 171st truth is that there may be aspects of the universe that are fundamentally unknowable, not because of a lack of effort or technology, but because of the inherent structure of reality. Certain regions of space lie beyond our observable horizon, and information from those regions may never reach us. This creates a natural boundary, a quiet edge beyond which observation cannot extend. And within that boundary, another subtle limitation appears. The 172nd truth is that measurement itself has limits. At the quantum level, principles such as uncertainty prevent us from knowing certain pairs of properties simultaneously with perfect precision. This is not due to imperfect instruments, but a fundamental aspect of how nature behaves. It suggests that reality, at its deepest level, is not fully deterministic, but includes elements of probability. As we reflect on this, another question emerges: the nature of physical laws themselves. The 173rd truth is that we do not fully know why the laws of physics have the form they do. Constants such as the strength of gravity, the charge of particles, and the speed of light appear finely tuned, allowing structures like stars, galaxies, and life to exist. If these values were slightly different, the universe might look very different, or might not support complex structures at all. Some theories suggest that many universes could exist, each with different physical constants. The 174th truth is that the idea of a multiverse remains a possibility. In this view, our universe is just one of many, each with its own properties and laws. While this idea is still speculative, it offers one possible explanation for why our universe appears structured in a way that allows complexity. And yet, even without confirming such ideas, the question itself adds depth to our understanding. As we move forward, another mystery comes into focus: the nature of time's beginning and end. The 175th truth is that we do not yet know whether time has a true beginning or an eventual end. While current models describe a starting point and suggest possible futures, the full picture remains incomplete. Time may extend indefinitely, or it may be part of a larger cycle. It may even behave differently under conditions we have not yet observed. And this leads to another quiet realization. The 176th truth is that our understanding of the universe is always incomplete, and that is part of its strength. Science evolves, adapting to new evidence, refining its models, and expanding its reach. Each answer leads to new questions, not as obstacles, but as natural extensions of discovery. As we consider these ideas, the concept of reality itself begins to soften. The 177th truth is that reality may not be as straightforward as it appears. At different scales, it behaves differently. What seems solid and continuous at one level becomes probabilistic and uncertain at another. This layered nature of reality suggests that there may be deeper structures beneath what we currently observe. And within those structures, connections may exist that we have yet to fully understand. The 178th truth is that everything in the universe may be more interconnected than it appears. From quantum entanglement to gravitational interactions, connections span distances and scales in ways that challenge simple explanations. These connections do not disrupt the calm of the universe. They enhance it, adding subtle complexity beneath the surface. As we move closer to the edge of this exploration, another thought begins to settle. The 179th truth is that mystery itself has value. It keeps curiosity alive, encourages exploration, and reminds us that understanding is a process, not a final destination. The universe does not require immediate answers. It allows space for questions, for reflection, for quiet observation, and finally, we arrive at a gentle conclusion. The 180th truth is that the universe is not only a place of answers, but of ongoing discovery. It does not present itself all at once. It reveals itself gradually, layer by layer, inviting us to explore at our own pace as you let this idea settle in. The need to fully resolve every question begins to fade. It becomes enough to simply observe, to appreciate the depth, to sense the quiet presence of something vast and continuously unfolding. The mysteries do not disturb the calm, they become part of it. Like distant stars that cannot yet be reached, yet still shine softly in the distance, adding depth to the night. And as your thoughts drift among these distant questions, there is a sense of openness that emerges, and no urgency, no pressure, just quiet curiosity at a universe that continues to unfold gently, steadily, without needing to explain everything at once. And as that realization softens into stillness, the mind begins to rest, carried not by answers, but by the quiet beauty of the unknown, where every mystery is simply another horizon, waiting patiently in the distance. Chapter 10. The ultimate fate of everything. As we gently approach the final stretch of this journey, the universe invites us to look not just at how it began, but at where it may be going. Not in a dramatic or sudden way, but in the same slow, steady manner that has shaped everything so far. The future of the universe is not an event waiting to happen. It is a process already unfolding, quietly, moment by moment. If we could move far forward in time, beyond the limits of human imagination, we would not find a sudden ending. Instead, we would witness a gradual transformation, a soft fading of activity, a shift from brightness to stillness. The 181st truth is that the universe is already evolving toward a quieter state. As time passes, stars consume their fuel, galaxies slow their formation of new stars, and the overall energy becomes more evenly spread out. This process is guided by the same principle that gives time its direction: entropy. The 182nd truth is that entropy continues to increase across the universe. Energy spreads out, differences become less pronounced, and systems move toward equilibrium. In simple terms, the universe is slowly becoming more uniform. But this change is not something that happens quickly. It unfolds over timescales so vast that even billions of years are only the beginning. The 183rd truth is that stars will not last forever. Even the longest living stars will eventually exhaust their fuel. Some will fade into white dwarfs, others into neutron stars, and some into black holes. As new star formation slows, the night sky, if it could be observed, would gradually grow dimmer. Galaxies that once glowed with the light of countless stars would become quieter, dominated by older, cooler stars that emit less energy. The 184th truth is that star formation will eventually cease. As the gas needed to form new stars is used up or dispersed, galaxies will lose their ability to create new light sources. This marks the beginning of what is sometimes called the stellar era's end. And yet, even after stars fade, the universe continues. The 185th truth is that remnants of stars will persist long after their light has gone. White dwarfs will cool slowly, neutron stars will remain dense and quiet, and black holes will continue to exist, holding on to the mass they have gathered. Over even longer timescales, interactions between these remnants will continue. Objects may collide, merge, or be ejected from their galaxies. Slowly, systems will lose structure as gravitational interactions redistribute energy. The 186th truth is that galaxies themselves will gradually change. Without new stars forming, and with ongoing gravitational interactions, galaxies will become less organized, more diffuse, and more quiet. Meanwhile, the expansion of the universe continues. Driven by dark energy, space itself stretches, increasing the distance between galaxies. The 187th truth is that distant galaxies will move beyond our observable horizon. Over time, their light will no longer reach us, not because it stops, but because space expands faster than the light can travel toward us. From any given point, the universe will appear increasingly empty. Only nearby structures, bound by gravity, will remain visible. And within those structures, the slow evolution continues. The 188th truth is that timescales in the far future become almost unimaginable. Processes that once took millions of years now stretch into trillions and beyond. Stars fade, remnants cool, and motion slows. The universe does not end with a moment, but with a gradual quieting that as black holes remain among the last active objects, another subtle process begins to take place. The 189th truth is that black holes are not eternal. Through a process known as Hawking radiation, they slowly lose mass, emitting energy over incredibly long timescales. For large black holes, this process takes far longer than the current age of the universe, trillions upon trillions of years. But eventually, even they will fade. And as they do, the universe approaches a state where almost all structured energy has dissipated. The 190th truth is that the universe may approach a state of maximum entropy, often referred to as heat death. In this state, energy is evenly distributed and no gradients remain to drive processes or create new structures. There are no stars, no active galaxies, no sources of light, only a vast, quiet expanse. And yet, even this is not a sudden end. It is a continuation of the same process that has been unfolding since the beginning. The gradual spreading of energy, the soft movement toward equilibrium. As you imagine this distant future, it may feel vast, almost beyond comprehension. But there is also something deeply calm about it. The universe does not collapse into chaos. It does not rush toward destruction. It simply slows, gently, steadily, moving towards stillness. And within that stillness, there is a quiet sense of completion. Everything that could happen has happened. Everything that could form has formed. And what remains is a calm, balanced state where nothing is forced, nothing is changing rapidly. Everything simply exists. As your thoughts drift into this far future, the sense of time begins to stretch even further. Moments lose their urgency. Processes slow beyond perception, and the universe becomes less of a place of events and more of a quiet presence of vast, silent space where energy rests and motion fades. And as that image settles, there is something unexpectedly peaceful about it. Not an ending to fear, but a quiet conclusion to a long, steady story. A story that began with energy and light and slowly, gently, returns to stillness. As we continue drifting into the farthest reaches of time, the universe becomes quieter still, not in a sudden way, but through a gradual softening of everything that once seemed active and bright. The glow of stars fades, the motion of galaxies slows, and the vast structures that once defined the cosmos begin to dissolve into a calm, even stillness. There is no single moment where everything stops. Instead, the universe gently transitions into a state where change becomes rare, subtle, and spread across unimaginable spans of time. The 191st truth is that even after the last stars fade, motion does not completely cease. Particles continue to move, fields continue to exist, and space itself continues to expand. But these movements become so slow, so faint, that they blend into a near-perfect stillness. In this distant future, black holes remain among the final active structures. Over trillions upon trillions of years, they slowly evaporate through Hawking radiation, releasing tiny amounts of energy into the surrounding space. The 192nd truth is that the final stages of black hole evaporation are incredibly subtle. For most of their existence, black holes lose mass extremely slowly, but as they shrink, the process accelerates slightly, eventually leading to their disappearance. When the last black holes fade, the universe is left without any concentrated sources of energy. The 193rd truth is that after black holes vanish, the universe consists mostly of low-energy particles spread thinly across vast distances. Photons, neutrinos, and possibly other stable particles drift quietly through expanding space. At this stage, there are no stars, no galaxies, no structures in the traditional sense. Only a vast, dark, and nearly uniform expanse remains. And yet, even in this stillness, the universe continues. The 194th truth is that time does not stop, even in a quiet universe. Moments continue to pass, even if nothing significant appears to change. Time becomes less about events and more about the potential for events. A quiet flow without noticeable transitions. Some theories suggest that, over extremely long timescales, even the particles themselves may not be permanent. The 195th truth is that certain models predict the eventual decay of matter. Protons, which make up the nuclei of atoms, may slowly decay into lighter particles over immense periods of time. If this occurs, then even the last remnants of matter will gradually dissolve. This leads to a universe composed almost entirely of radiation and fundamental particles, spread so thinly that interactions become exceedingly rare. And yet, even in such a state, the story may not be entirely complete. The 196th truth is that some theories allow for new beginnings, even after long periods of stillness. Quantum fluctuations, tiny, random variations in energy, could, under certain conditions, give rise to new structures or even entirely new regions of space-time. These possibilities remain speculative, but they suggest that the universe may never truly reach a final, absolute end. Instead, it may continue in ways that are subtle, quiet, and difficult to observe. As we consider these ideas, another realization begins to form. The 197th truth is that endings in the universe are rarely absolute. What appears to be an end is often a transition, a movement into a different state, shaped by the same underlying laws. Stars end, but their material continues. Galaxies change, but their motion persists. Even black holes fade, but their energy returns to space. And so, the universe evolves not toward disappearance, but toward transformation. The 198th truth is that the universe is defined by continuity. It does not abruptly stop. It changes form gradually and consistently, following the same quiet principles that have guided it from the beginning. As the universe becomes more uniform, more still, more balanced, there is a sense that it is reaching a kind of equilibrium. Not a dramatic conclusion, but a gentle settling. The 199th truth is that equilibrium is not emptiness, but balance. It is a state where differences have smoothed out, where energy is evenly distributed, and where change occurs only in the most subtle ways. And finally, we arrive at the last truth, a reflection that brings everything together. The 200th truth is that the universe, from beginning to end, follows a quiet and consistent path. It begins in energy and expansion, builds complexity through simple rules, and gradually moves towards stillness. And within that entire journey, you exist. A brief, conscious moment within an immense timeline. Formed from the same atoms that were once inside stars, shaped by the same forces that guide galaxies, experiencing a small part of a much larger story. As this realization settles in, there is something deeply calming about it. You are not separate from the universe. You are part of its unfolding, and just as the universe does not rush, does not force, and does not resist its own flow, there is no need for you to do so either. Everything moves at its own pace. Everything unfolds as it should, And as your thoughts gently drift across this vast timeline, from the beginning through the formation of stars, through the quiet expansion of galaxies, and into the distant stillness of the future, there is a sense of completion. Not an ending that feels abrupt, but one that feels natural. A slow fading into calm. A gentle return to quiet. And as that quiet deepens, the universe itself seems to soften, stretching out endlessly, steady, silent, and at peace.